what? Water, chloride, and calcium with the DTA that form a complex Ca Y2 minus. Okay, and this is the complex. Okay. Okay, that is the point. Okay. But okay, but we need an alkaline solution, you say. This is not alkaline solution. This is an acid solution. Okay? That's true. In fact, boil the solution. Boil the solution, so you need a tripod, and then the Bunsen, okay, everything, the gas, bring with you the lighter. Okay? Chi fuma? Okay? No, well, not everybody has to bring it, at least 1 in 10, no? That's okay. Okay. Okay, so this is a point important because you don't have to waste your time. Because every time you have to make a titration, you have to go and wait. You don't have to wait the same amount. Because if you wait more than before, your ADTA will be more than before. So the ratio will be always the same when you make a calculation. So don't worry. Okay, so you have to boil it, and then after boiling, okay, you have to cool it, and then dilute to 80 to 100 milliliters. How to cool it? Okay, so to cool it, you have to do it this way. You have to go in the sink, open, okay, and then start to cool outside the flask, okay, the conical flask, okay, yeah. But how to hold the flask, because it's quite hot. And then you do it this way, take a filter paper, okay, and do it this way, take a filter paper, okay, do it this way, okay, put it around the conical flask, and see, in this way, you go nearby the sink, and then you let the water going outside, okay? And then with the other hand, you just test it to see if it's cool. Then you dilute it, and diluting it is even gets at room temperature almost. Okay, you don't have to stay at room temperature. It could be even a little bit warm, but it doesn't matter. So this is the way, okay, to do it. Otherwise, it will take a lot of time. And don't do this with the forceps, okay? Because if you do this, you can break it, okay? Best way is doing this, okay, this way, okay? Is this clear? Okay, everybody knows now, okay? Okay, let's continue. Okay, then after this operation, you have to add that ADTA, magnesium ADTA, as before, 2 milliliters of ammonia buffer, okay? 5 milliliters of ammonia buffer, and the indicator. Before adding the indicator, okay, you have to be sure that your solution is alkaline. So going back to alkaline, because you add drop by drop, drop-wise, you add chlorhydric acid, hydrochloric acid. Then when you put this ammonia buffer, you have to be sure that the ammonia buffer worked. Okay, so put the back to the alkaline, solution, your compound. Okay, how to do this? Well, if you ask the technicians there, so you can check it with a paper, okay? It's a pH paper. But just think, if you do this, you you consume it. Yes, but the drop doesn't matter, okay? Doesn't matter, okay? Even even if your glass stick is wetted, that's all. It's even less than 1 drop or half drop. So don't worry, okay? So the amount that you lose is insignificant, okay? It's negligible. Okay. Okay, and then you put the indicator, so this net, okay? Then you start the titration with the DTA, okay, until the color change. There should be good color change because it's using the magnesium, okay? Should be from red to blue, okay? Is this okay? Now the calculation. How to do the calculation? Okay, so you weighted a certain amount of your unknown compound, okay, and then you can calculate with the grams of calcium carbonate according with the amount of milliliters of DTA that you used. Okay? So the grams of carbonate, calcium carbonate, are given by the molarity of DTA, or normality, then we will see, doesn't matter. Time the concentration of the milliliter of DTA that you used, okay, time the molecular weight of calcium carbonate, which is 100.09, divided by 1000 to convert the millimole in mole. Okay, this is okay, and these are the grams of calcium carbonate. Then the amount that you weighted, okay, and the amount of that you found. Okay, so found divided by weighted times 100. Yeah, well, yes, found. Yeah, because you will find calcium carbonate which is less than what you weigh, because your sample is contaminated by an inert substance. Okay, so your compound is not 100% calcium carbonate. Is a percent, okay? So by the ratio of what you found, what you weigh, times 100, you calculate the percent.
Quindi dobbiamo fare sempre la percentuale, vedo tutte.
Okay. Okay. This time you are titrating what you weigh directly. Last time you weighed it and then you diluted it, okay, and then you diluted it at 250 milliliters, and then you picked up only 25. Then the total amount is in the 25 times 10, not in this case. Yeah.
But this time the mean between the found the deviations would be on the grams of calcium carbonate.
This time you weight it a certain amount, and then this amount is, for example, 260 milligrams. The amount of your DTA will be more than 250.
So the mean will be on the grams and not on the
Exactly.
volumes.
So you have to calculate each time by the grams and the volume, because you know that there is a proportionality between grams and volume used. Grams and volume used. Okay. You have to do at least 3 titrations. Okay. You can do even more if you want.
Isn't it better to the mean of the percentage, since we don't
It depends, because the percentage should be always the same. then you can do the mean of the percentage. Correct. Yeah.
Instead of the,
Yeah, because each
when
time
you wait,
each time you get a percentage, but the percentage theoretically should be always the same. Because you use more volume of DTA if you weight more amount of your compound. Okay? So at the end, the calculations, since you have only multiplications and division, so the results should be the same. But since there is the error, of course, the best thing to do is to calculate each time for each titration the percentage, and then making the average of the percentage. That's correct. Okay. Or you can do the average of the grams and then to make the percentage. It's up to you. It's the same. Okay, the same amount, same thing. Okay.
Just do it as a touch of frequency. Touch it. Send it to Amir. Amir's favorite thing.
Yeah, I know.
perché se vogliamo troppo va.
Okay, it's a short, then we will read. Okay.
ETA is a simple keyword that can be used in the analysis of many metals. In this case, we're doing an analysis of calcium. The calcium samples are aliquoted into a flask and rinsed down with DI water. As this analysis, we will be using ureachrome black tea as the indicator. Like EDTA, ureachrome black tea is a QID